Alright, hey everyone, this is question 7 from our slope fields packet. It says consider the differential equation dy dx is equal to negative 2x over y. And we're going to focus on part B here. It says let y equal f of x be the particular solution to the differential equation where the initial condition f of 1 is equal to negative 1. Run an equation for the tangent line to the graph of f at 1, negative 1, and use it to approximate f at 1.1. So, what is our differential equation? Well, if we look above, we see that our differential equation is dy dx is equal to negative 2x over y. And we want to get a line that's tangent to this point. Well, to get a line, we need a slope. And to get a slope, well, dy dx represents the rate of change. And we have a point, 1, negative 1. So why don't we substitute in positive 1 for x and negative 1 for y. And when we do that, we have negative 2 over negative 1, and we get positive 2. So our slope for this tangent line is positive 2. But we want the entire line. So in order to get our line, what we want to do is, well, point slope form is y minus y1, and our y1 value is negative 1, right here, y1, is equal to our slope, 2, and then x minus x1, and our x1 value is 1. So from this, we get y plus 1 is equal to distribute the 2, 2x minus 2. We're going to subtract 1 from both sides. We have y is equal to 2x minus 3. So that's the equation of our tangent line. So now from this, it wants us to approximate f at 1.1. So to approximate f at 1.1, let's rewrite this in function notation. Instead of y, f of x is equal to 2x minus 3. And we want to find f at 1.1. So that's 2 times 1.1 minus 3. And 2 times 1.1 is 2.2 minus 3. And f at 1.1 will be negative 0.8. Alright, so that is part B. So part C says find the particular solution, y is equal to f of x, to the given differential equation with the initial condition y is f of 1 is equal to negative 1. So anytime we want the particular solution, we need to take our differential equation, dy dx is equal to negative 2x over y, and we need to separate and then integrate. So multiply y by both sides, multiply dx by both sides, and we have y dy is equal to negative 2x dx. From this point, we want to integrate both sides now that we have our y's and x's on each side of our equation. And when we do that, we have y squared over 2 is equal to negative x squared plus c. Now, with that being said, we had the condition that f of 1 is equal to negative 1. So I'm going to substitute in negative 1's our y value. And then for x, we have positive 1. And we're going to find what's our c value. So we have positive 1/2 is equal to negative 1 plus c. And when we add 1 to both sides, we'll have 3/2 is equal to c. But that's not our particular solution yet. All that tells us is what our c value is. So after we integrate, we had y squared over 2 is equal to negative x squared plus c. Well, our c value is 3/2, right? So here we are. Y squared over 2 is equal to negative x squared plus 3/2. Now we want to solve for y. So to do so, I'm going to multiply everything by 2. So we have y squared is equal to negative 2x squared, and then plus 3. And I'm going to take the square root of both sides of our equation. So y is equal to, and we take the square root, we really get plus or minus the square root of negative 2x squared plus 3. And the reason I'm doing this is, well, our particular solution, we were given a y value that was negative. And since we were given a y value that was negative, we need to account for both the positive and negative potential solutions that we have here. So we are not taking the positive solution. We're going to take the negative solution. So we're going to have y is equal to negative the square root of negative 2x squared plus 3, which will represent our final solution. And again, the reasoning for this is if I am to plug in positive 1 for x, I'll have inside of my square root, it'll be the square root of negative 2 times 1, which is negative 2, plus 3, which is positive 1, right? But the square root of positive 1 will be positive 1, but we want it negative 1, so therefore we have to have that negative outside of our square root to satisfy that solution. I hope you found this video helpful. Let me know if you have any more questions.